Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. Today, I'm joined by Jeffrey Martin. Jeffrey is the co-founder and CEO of Mosaic, a company building 360-degree camera systems designed specifically for mapping. He's been obsessed with 360 imagery for over 20 years. He built one of the very first websites combining panoramic images with a map back in 2005, before Google Street View even existed. And he's even got the Guinness World Record under his belt for a 320 gigapixel image of London stitched together from 52,000 photos shot off the rooftop of the BT Tower. So yeah, he knows a little bit about 360-degree imagery. So in this conversation, we get into what a modern mapping grade 360 camera actually looks like, the difference between rolling shutter and global shutter sensors, and why that matters if you care about things like colorizing, point clouds, or photogrammetry, and the surprising long tail of people who need up-to-date street-level imagery. And the list is pretty long of people that need up-to-date street-level imagery. Everyone from departments of transport, utilities companies inspecting infrastructure, to playground designers and outdoor furniture salespeople. We also talk about how this kind of ground-level capture fits alongside with drones and satellites, where it slots into the autonomous vehicle conversation, what a comparison with something like Hive Mapper looks like, and where Jeffrey thinks cameras and AI are heading over the next 5 years. I hope you enjoy the conversation. Hi, Jeff. Welcome to the podcast. Thank you for showing up on such short notice. You are the CEO and founder of something called Mosaic. We're going to talk about that a little bit more later on, well, a lot more. And I want the focus of this to be around 360-degree imagery, what we can do with this. And bear in mind, this is a geospatial podcast, so there'll be a focus on that side of things as well. So that's a very brief introduction. Maybe you could fill in a few details for us. Who are you? What do you do?
Great. Thanks for having me on the show. So my name is Jeffrey Martin. I am originally from the U.S., living in Prague now, and I am a co-founder, CEO of Mosaic. We make geospatial 360-degree camera systems for mapping. I have been involved in various aspects of 360-degree imaging for over 20 years now. My first foray into that resulted in building one of the first websites combining 360-degree images with a map. This was back in like 2005. So there was no Google Map at all. There was no Google Street View. It was still a few years away. Then I built a company around that called 360cities.net, which is still online. It's a publishing and licensing platform for artistic high-resolution 360-degree images. After that, I started a company called Sphericam. This was around 2016. If you remember the VR hype train of 2016, Oculus getting bought by Facebook and the whole world going crazy over VR headsets coming out, lots of VR cameras coming out. So I was in the middle of that. That didn't end up panning out the way people thought it would. And I kind of pivoted Sphericam into Mosaic. So going from sort of a VR camera, 360-degree camera for consumers to a more industry-oriented, focused use case of 360-degree imaging, specifically for mapping. And that's where I am today.
Just before we push the record button, there was some mention of the Guinness Book of World Records. What was that?
Oh, that's right. So I've been generally sort of obsessed with 360-degree imaging for a long time, just trying to push it as far as I can. So back in the day, you would make these images by just using a DSLR and taking a bunch of pictures in a circle and stitching them together. You still can do that. People still do that. And so I kind of pushed it in two directions. One is like, how can you make video out of this? So I'm cobbling some kind of video cameras together. And the other way to push it is like, how high resolution can you make this? So instead of taking just 4 pictures in a circle with a fisheye lens, you can put a zoom lens on your camera and take more pictures. You take 50, 100, 1,000, 50,000. So I started making these gigapixel images, so-called gigapixel images, where there's a megapixel, it's 1,000,000 pixels. A gigapixel is 1,000 megapixels. So started making these from like the tops of various buildings in the world, and got a few interesting commissions. And then BT, British Telecom, approached us and said, "Hey, we'd like to the Olympics, and how about we make a world record?" So we were like, "Okay." So from the top of BT Tower in London, which incidentally was not on any official map of London until 1984, even though it's like the tallest building in London. Anyway, so we were up there for about 3 days and shot multiple data sets comprising 52,000 photos, and stitched them all together into a 320 gigapixel image of London, which is still online. You can find it if you Google London gigapixel world record or something like that. You'll find it. Also did some gigapixel images inside stadiums, like during a football match, like at Wembley at the FA Cup final, where you could zoom in and see every single face, and so sort of like a fan camera where someone was at the match, and then they could go back later and find themselves and share it on social media, and that was fun. So yeah, done all kinds of different types of 360-degree imaging.
That's fascinating. 50,000, what did you say? 52, 53,000 images.
Yeah, yeah.
Wow, that's a lot of stitching. That's a lot of stitching those things
It was.
together.
It took quite a while. It took a few months to get it all put together.
Yeah, fascinating. Okay, and now here we are with Mosaic. So this is the company you're a co-founder of, and these are mapping 360 cameras. What does the camera look like? We talked a little bit about pixels resolution before. Can you give me the details of the camera?
So the camera is approximately the size of your head, and it is mounted on top of a car. It's all metal. It's water resistant, passively cooled. It has 6 cameras on it. There's 5 cameras going around in a circle and 1 camera pointing up. There's a antenna for the GPS, GNSS, and cables going into your car. You can control the camera with any device that has a web browser. And generally, the camera's mounted about a meter above the roof of the car, give or take. And it allows you to have a decently high resolution, not a gigapixel, but about 72 megapixels. There's six 12 megapixel camera sensors in the device. They're all perfectly synchronized all the time, and it has been quite diligently engineered to have good sharpness across the lenses, good balances of colors, and we've tried to make it usable and easy to use for this specific type of activity. So it's not like a generic industrial camera that can be used for anything. It's more specifically designed for this specific type of activity. And we've tried to make it as good as possible for that.
And when we say camera, we're talking, are they RGB cameras, RGB images it's creating, or something else?
Yes, they are RGB images. We have 2 distinct models. One uses rolling shutter sensor. That's the more affordable option. And the other uses global shutter sensor.
What does that mean?
That has bigger sensors and bigger optics. So camera sensors come in 2 general flavors. There's rolling shutter and global shutter. Global shutter means all the pixels are captured at the exact same moment. And this is more difficult and more expensive as a product. It has certain trade-offs in terms of like noise and other stuff, which is why it ends up being more expensive. Rolling shutter sensors read out the pixels line by line. This is what the vast majority of image sensors use. All smartphones and all like mirrorless cameras use this. Generally, you have a mechanical shutter in front of the rolling shutter sensor. In the case of like a professional mirrorless camera, generally rolling shutter sensors have better dynamic range and lower noise, but as they read out the image line by line, there can be some geometric distortion to the image. And you might have seen this if you pan a camera really quickly, the vertical lines will become sort of bent and no longer vertical. So for a camera that is being used 8 hours a day, every day, you can't have a mechanical shutter in front of the sensor because it will wear out very quickly. So you have to have an electronic shutter. That means if you want to have some, geometric fidelity, you need to use global shutter image sensors. So our Mosaic X, which uses the global shutter sensors, is more suitable if you want to do things like colorizing point clouds or photogrammetry, doing measurements, things like that. And our more affordable camera, the Mosaic 51, uses rolling shutter sensors. And if you just want like Google Street View style panoramic images, that's perfectly sufficient. If you're driving really fast, then some vertical lines might not be vertical, but that doesn't matter much if your goal is just to have images.
When you talk about point clouds, these are point clouds that are created from the images. We're not talking about LiDAR.
So both are possible. Generally, I'm talking about LiDAR though. So we build the cameras, but we also do a lot of integrations, and we have one product of our own that combines the camera with LiDAR. And we have a lot of customers who use like a TRK, Trimble, Regal sensors. So we put a lot of work into making these integrations flawless. All of the synchronization is very accurate and precise. The triggering is all working so that every laser pulse emitted by the laser profilers or LiDAR is exactly known, and we know exactly which pixel from our camera can be used to give that laser point a correct color.
Yeah, I can't even imagine the engineering that went into figuring all that out and making it work consistently over time.
It definitely took a while, and we're quite proud of the fact that it all works really well now. It did take a lot of work.
So what are people doing with these cameras? So we talked about like it being specifically designed for mapping. Maps are a lot of different things. So collecting this amazing 360 imagery, what are they doing with it? Are they creating structure from motion? Is it building 3D scenes out of it? Is it a Google Street View style thing where they're just looking at images and clicking through them? Or are they extracting objects from it? What are they doing?
So I would say the bulk of our customers are doing the somewhat underappreciated task of making sure the world doesn't fall apart. So they are documenting the built world or on behalf of local governments, departments of transportation, utilities companies, telecommunications companies. So all of our built world, all of our roads, street signs, utility poles, electricity pylons, power lines, all of this needs to be maintained, and it would be good to fix it before it fails or falls apart. It would be good to trim the vegetation before it hits a power line and causes a forest fire, which does happen. So generally, these people who are doing inspections, a lot of them are surveying or engineering companies. They're in various stages of moving from the previous century to the next century in terms of this process. So there are still a lot of people walking around with clipboards checking the encroachment of vegetation to power lines. There's still a lot of people inspecting stuff by hand. This is obviously takes a long time, it's labor intensive, and requiring someone who is an expert to do this labor intensive task is inefficient. So it would be more efficient to capture the images wholesale and in some automated way do whatever detections you need to do and allow the experts to be only in the office rather than out in the field. So yeah, most of our customers are inspecting the roads, inspecting the telecommunications or power infrastructure and things like that. Other customers are making entire maps. So we have a customer in Europe who is capturing the entire country every 2 years. They do it better, more often, and more thorough than Google, who only goes there every few years and only captures about 75% of the roads. They get about 98% of the roads, and they do it every 2 years. Their main customer is a government agency who's able to check that properties are what they say they are, that there haven't been any illegal additions or construction going on. But they have a lot of other customers who can have access to this like countrywide set of images that is up to date, as opposed to Google Street View, which is often not very up to date. So, for example, they have a customer who makes outdoor furniture, and they can check all the restaurants and see who's got like old furniture, and they can call them up and say, "Hey,
You're kidding.
you might need some new outdoor furniture, eh?" So there's quite a long tail of different types of people who want to access like street view imagery, especially if it's up to date. There's a very, very long tail of people who you might not expect that can get their jobs done more easily by having access to this type of data.
What's the weirdest use case you've heard of?
Like these outdoor furniture people or like playground designers. If you're designing and selling playgrounds, how can you get a handle on like what is out there? Well, kind of hard. You don't want to like drive around forever looking for playgrounds, right? So this is quite interesting. And then we've done some data collection, and we have some customers who've done data collection for movie studios. So this is more like 3D reconstruction and photogrammetry for various movies. We worked on a movie called The Gray Man. It was a Netflix big budget movie, a Bollywood movie called War 2, the sequel to War 1, I guess. Uh, and a short film called The Ice Cream Man, where we scanned part of Amsterdam.
Yeah, funny. Brilliant naming. War One, War Two. I wonder where they're going to next with that. It'll be fascinating to see what they come up with. So some of those use cases, I imagine anyway, you're talking about an incredible volume of imagery you need to look through to find that. Unless let's say you already know where I'm only interested in the street, and then it might be conceivable that you can click down the street and look. But other times, like you think about satellite imagery, for example, there's so much of it coming out of the sky that the vast majority of it is never, ever, ever seen by human eyes. It's computers that are looking over it, deciding that, oh, this tree is too close to the power line. Let's do something about it. Here is a crack in the road. So we're identifying features that we're interested in and extracting them and creating a line, a point, a polygon in some other database somewhere so someone can go and look at that particular thing. Is that the kind of thing that you're involved with as well, or are you simply capturing the imagery?
So we're getting more into that. Right now, we are mainly involved in the data collection, and then this detection and extraction of features is downstream from us. We are gathering more and more features on the management of our data. So this is something that we're slowly moving into. Currently, our customers use various types of tools to extract features. They use like Topodot, for example, or various AI automated point cloud classification software to classify their point clouds or images.
Have you heard of anyone uploading it to Mapillary?
Oh, yeah, there are customers who upload their data to Mapillary. I think the city of Detroit has been one of the bigger power users of Mapillary. They've been using some kind of thimble device, and they've recently purchased one of our systems as well. And they've been mapping like the whole city of Detroit, I think like every year or many years, and they put it all on Mapillary. It's a good value proposition for certain types of users who don't want to deal with the infrastructure of hosting this data, which can be substantial, and where they might have a requirement or directive for their data to actually be public or accessible. So Mapillary, it's like free hosting. The data is available, and yeah, I guess it's strength or a weakness depending on what type of user you are. But if you're that type of user, then it's a really great value proposition.
Yeah, and also the object detection they do and the extraction they do, I think is pretty fascinating, and they're improving it all the time. I think it's for governments. I think local body governments. I think it's probably a really good idea.
It is a really good idea, and they do a very good job. You're correct with their object detection and extraction. It's something they've been working on for many years. It's very good quality. They have lots of categories. They have lots of different geographic regions. So the actual quality of the training is very good. And yes, it's a very good deal if you don't mind your data being available.
Yeah, public. Yes, yes. Good caveat to have in there. What is the sweet spot for your style of imagery collection? Because the reason I'm asking this, we're talking about trees hanging over power lines could cause a fire. I've talked to a few companies that are working on doing this via satellite. I've seen other companies trying to solve this particular problem with drones. But I could imagine maybe an urban setting might be a place where drones would struggle and where satellites would struggle. Could that be a sweet spot for you at Mosaic, or is there some other spot that is like the category that you own?
Yeah, so you're right about drones and satellite imagery. So it's very good at certain types of things, and it really falls flat at other things. So satellite imagery, obviously, the angle where it's looking is fixed. The resolution is fairly limited. It's always getting better, but it will always be limited by the laws of physics. Drone data, it can often be much better than satellite imagery. It still has the same issue where it is up there and there's only certain directions where it can look. If there is some occlusion, if there's trees or overhangs, it can only see what it can see. So it does have some limitations. And of course, there is the fact that getting permission to fly a drone is often difficult or impossible. So drone imagery and aerial imagery absolutely has its place. It's a huge industry, but it has limitations. It has some like hard limitations. So that's where we come in. We capture our images like at the human level. So it's where the people are, it's where the infrastructure is, and it's not looking straight down. It's looking straight ahead and upwards. So it can see things that are just not possible ever to see using drones or using aerial imagery. You can combine these things. You can fly a drone and use our cameras at the same time, and then you can fuse this data into a truly stunning, amazing quality 3D model. And there are people doing that, and we can share something with you later. We're working on improving this process all the time, and it's really exciting because this combination is special. It's not easy, but when you get it right, it's really amazing.
Well, I look forward to seeing that. So, is anyone just putting a camera on their back, on their on their head, carrying it around, going through pedestrian areas? Because it seems to me that we talked about it being mounted on a car, and I can see why you'd want to do that. But I'm thinking about, is there any market for mapping at this kind of resolution using this technology inside or these sort of pedestrian areas, bike paths, that kind of thing?
Definitely. So our main products are the cameras that you put on a car for kind of large scale mapping of large areas. This is clearly the most efficient way to do it. But we also have a backpack product called the Explore, and this is also using global shutter sensors. It's similar to the camera you put on the car. It adds a couple of LiDARs. So on your back, you have 72 very sharp megapixels of RGB camera data. You have two LiDARs, you have a GPS antenna, and an IMU. And this allows you to go anywhere. You can go on foot or on bicycle or on a scooter. You can go outdoors. You can go indoors. There's definitely a healthy and growing demand for mapping of places where you can't go with the car and indoors. As far as like the outdoor mapping goes, there are countries like India, for example, who have a lot of narrow streets and where driving a car might be inconvenient or difficult or dangerous, and it's much more sensible to mount something onto a motorcycle or scooter or bicycle and map these, narrow passageways that way. Indoors is a little bit different. So that's where we get into some other industries than pure geospatial. We've got facility management, construction, industrial documentation of warehouses, factories, power plants, oil and gas facilities. So, like the geospatial world, you need to be sure things aren't falling apart or they are as they say they are. So, especially like oil and gas, you've got oil refineries, you've got, all kinds of facilities that are very complex, very prone to different types of failures. And there's a lot of effort put into inspecting these places very, very carefully. Be sure that there's no corrosion and there's not going to be any failure because in those cases, any downtime can be extraordinarily expensive.
This might be a question that's slightly difficult to answer, but I'm wondering if the way we capture imagery will need to change when we start thinking about how do we build maps for autonomous vehicles. If you think about, like, especially that last mile problem, it seems to me like the kind of imagery that you're capturing and the kind of detail you're capturing it in, and I guess the maps you could build off of that might be fantastic for that kind solving that kind of problem, giving these robots a base map to sort of move around in.
Yes, and this is a topic that I've been diving into in my free time. The whole topic of what sort of framework a robot or embodied minds in general need to use in order to function properly and safely in the world. And yes, you're correct. And the current crop of autonomous cars are very heavily dependent on a prior or having available some kind of reference by which they can judge what's going on. So you have like these Waymo cars, or I guess these Tesla cars that are crashing all the time, who are trying to, sense where they are and what's going on, and they all rely on, reference map that was created using cameras and lasers for them to understand where they are and what they should do. And I think that this is still being solved in a fairly primitive way. It's starting to work. Like you can see that Waymo is succeeding, although crucially, they're not saying how often humans are helping. And the general mechanism by which these cars are operating, I think it still needs a lot of work for them to operate safely in an unfamiliar environment. These Waymo cars are in American cities with good weather where the drivers aren't too crazy. Like, I don't know, put a Waymo car in southern Italy or in Delhi, and it's not going to work. It's just going to stop and kind of wait for the street to clear out or something.
Yeah, yeah. Hey, speaking of self-driving cars or autonomous vehicles, slightly different topic, but have you come across a product, a company called Hive Mapper?
I have, yes.
Yeah, so I've been talking to them on and off for years now, and they originally tried to do what they're doing with 360 cameras, and they just could not get it to work. So they went back to they ended up building their own hardware, and now that's what they use. But they could not get it to work with 360. So they just I think they've got two cameras at the front now, so they get more depth,
Okay.
but that's it. And it's an interesting approach, I think. Like it's kind of decentralized this idea of building really detailed maps. And the reason I bring it up now and at this stage in this conversation is because part of what they're doing, their big focus is not so much documenting the world, like the infrastructure, it's building maps for autonomous vehicles.
Okay. Yeah. Hive Mapper, it's a little bit similar to Mapillary in terms of it's a kind of large scale type of data collection using more off the shelf types of cameras. So the result is that you have a lot of imagery. It might not be as comprehensive or high quality in terms of the image quality as a dedicated camera that is used for mapping.
I think that's very kind of you. When I look at the resolutions of your cameras and I think about the way you've just explained it, it's definitely you've definitely got a higher quality product. But I think there's two different approaches as well.
That's right.
Like, you're going for the one extremely high quality product, and they're going for like how many images can we get, and what is the repeat time? I think.
Right. And I guess what they're doing, it's sort of they're mounting cameras on cars that are driving around anyway. One of the practical issues with that in terms of mapping is that you've got this kind of power law where most of the cars are going on only a few streets, and most of the streets you don't ever drive on. Like, even in your own neighborhood, most of the streets you just never go down, you never have a need to go down. So to get a comprehensive map, it's always kind of tempting to mount cameras on taxis and stuff like that, but you might be surprised how little of the region that you'll actually capture. You'll end up capturing all the main roads a lot, but none of the side streets. I guess Hive Mapper gets around that by sort of offering some kind of cryptocurrency for people who cover areas that are needed to cover and stuff like that. So yeah, it's a very interesting take on mapping. Generally, our thesis is that we want to do it in the best possible quality, and I mean, there's a market for both ways, and there's certainly benefits to capturing a few of the main roads very frequently. There is some data that can be derived from that for sure.
How do you think your business, your technology is going to change over the next 5 years? Like AI changing everything. What do you think Mosaic is going to look like in 5 years' time, either in terms of the technology and perhaps who is using it? My guess is that like more technical systems like yours are going to be more available to people, more accessible to more people.
So I think that is definitely correct. I think generally the path of technology in general is that it becomes easier and more accessible and cheaper, and when it does, it becomes more. You get a bunch of interesting use cases out of it that you didn't expect or imagine. I know that, like with Mapillary, one of their customers is like it's I don't know if it's Washington D.C. or which city, but it's like the leaf clearing trucks, and they can like keep track of what streets need their leave cleared, and this is kind of funny. And so in 5 years, I think there will be a lot of interesting ways that large language models are used with the data. I think our use of this type of AI, these chat GPT type LLMs, like the whole world is still figuring out what to do with this thing, what to do with this technology. So like the first thing is a chatbot, the second thing is vibe coding programming. But I think there's a lot of other interesting things that we will figure out what to do. And I'm already seeing people who are somehow connecting a database to an LLM, and then you can ask it questions. The challenge with this type of image and geographic data is like, how do you parse this data in a way that can be ingested by a large language model in a coherent and effective way in order for you to be able to ask it questions? And that is not an easy question to answer. And I think it's going to take a while for a lot of different people to figure out the best way to do that for whoever the target customer is. But I can imagine like you map a whole city or country, and then if you can understand what's in the images, then you can have an interface for finding things out in a way that is much more easy and human centric. So you can say, show me where the vegetation's getting too close to the power line, and it'll show you that. Or you can imagine all kinds of strange questions that you might be able to ask it that would otherwise not be possible.
So in the satellite world, the Earth observation world, there's a lot of focus, a lot of excitement around these foundational models now. And the whole idea is that you take all of the satellite archives and just boil them down till you get a bunch of vectors. And of course, I'm like oversimplifying everything dramatically now. A bunch of vectors, and then you can use this to say like exactly what you're saying in the world. Like, show me all the pieces of, I don't know, beach in this country. Show me the forest. Where's the forest? Kind of thing. And again, massively oversimplifying. But it seems to me that someone like you, a company like yours, you would be in a position so that the country that you're talking about that's using your equipment to map all the streets in their country every 2 years, they would be in a position with that kind of data archive to create, foundational models for their country, I guess.
That's right. And that's where things get interesting and exciting. And I think, and it will take a few years. Like, I think everybody's still sort of figuring out and dipping their toes in this whole idea, which the idea itself didn't exist 5 years ago. And now the idea exists, but how to execute that in the best possible way is just, I think, going to be a trial and error process. And we don't know the answer to how to do that.
This is another sort of future gazing question. I hope you don't mind. When I think about cameras, I think about the two things that I see in terms of the technology over time has been, or a couple of things, is they've gotten a lot smaller, significantly smaller. They've gotten the resolution has increased and they've got a lot cheaper. And they have magic in them now, AI magic in them. So everyone's a great photographer now. Where do you see this is going in terms of just cameras? Is it just smaller, cheaper, faster, more of that? We continue along that line. Do we continue along more magic, more AI in them, or is there some sort of technology jump on the horizon that you can see that's going to change all this?
I'm very bullish on the future and I love future gazing. But I think with cameras, we are approaching a plateau in terms of physics. Like, you have smartphone sensors that are 200 megapixels, and each individual pixel is smaller than the wavelength of light that it needs to detect, which is a physics problem that they're solving, but you can't keep shrinking it down, and you can't keep shrinking down the optics, at least with the current technologies that we have to create optics. There will be others. There's also the question of, like, what do you need to be able to see? So in terms of, like, just the pure resolution in megapixels, I don't really see, like, there's no longer really much of a megapixel race like there was 5, 10, 15 years ago, where every year or two there's a new camera that's coming out that's more megapixels. It's not really happening so much now. And I think, like, smartphone photos are still about 12 megapixels. Even if you have a smartphone sensor that these days, a lot of them are like 48 megapixels, but those are like shrunk down into 12 megapixel images with better colors and better dynamic range. But the actual quantity of pixels that people need seems to be about 12 megapixels for just cameras that people have in their pocket for taking photos. So the evolution now with cameras, it's in not the resolution, but like the quality of the image. So what is the brightest and darkest stuff you can have in the same picture and still make it look good? So all this kind of HDR tricks, and yes, there are these kind of computational photography tricks that are being done. So the same 12 megapixel photo that you've got on Google Photos from your smartphone camera of today, it does look dramatically better than the 12 megapixel photo that you took 12 years ago. It's the same number of pixels, but it does look a lot better. So the resolution has sort of plateaued. The image quality, I think, can continue to improve, but I think we're kind of like hitting the limit. Just like in the film world, before digital cameras, like, the camera film also sort of reached a limit of what could be created, and yeah, they incrementally improved it over the years, but at a certain point it was as good as it could get and can't really make it much better.
So at the moment, you have RGB sensors in your cameras. Is there any need? Is anyone saying, hey, we'd really like some other kinds of sensors here? We'd like to be able to see other stuff? Or is RGB fine?
I think the most frequent request we've gotten is for thermal cameras. So if you can see where places are hot or cold, like if you can see the roofs of houses or certain parts of the power line, the infrastructure like transformers, if you can see which ones are hotter than other things, there have been some requests for that. So for thermal imaging, yes, not really for other areas of the spectrum, not really like UV, or I think for like vegetation type stuff, this is better handled by top-down, like aerial cameras or drones. But certainly adding some thermal cameras would be cool for certain folks, not everybody.
But that would be cool. That would make for some really, really interesting data to look at.
It would. It's always interesting to look at the whole electromagnetic spectrum and see like what our eyes can see, and it's like not very much. There's a lot more waves out there that we can't see at all, and sure would be something to be able to see more of that stuff.
Yeah, it's pretty crazy, especially with thermal. There's something about thermal. So I was at a sports store the other day looking at thermal binoculars, and I'm
Oh,
fascinated
cool.
by all this stuff. So looking at these binoculars, and the guy that was the sales rep who was showing me them said, "Oh, watch this." I said, "Look at my feet," and he walked across the carpet, and I could see he was wearing shoes. I could see where his foot was touching the carpet, and I could also see as his foot came down, like the thermal effect, you could see it intensifying until it touched the carpet, and also when it left on the other side. And it stayed there for quite some time. It was really, really fascinating.
Wow, and he was wearing shoes, huh? Wow.
Yeah. Yeah. No, it was really cool. I don't know how much magic is happening there in the background, but like it was pretty cool. And like you were saying, there's so much we can't see.
Hmm.
We're really restricted to quite a limited band. So
Yeah.
thermal's fascinating.
Hmm.
Hey, listen, Jeff, I want to thank you very much for your time. I realized this whole thing was short notice, but I appreciate you coming on and teaching us something about 360 imagery.
That was great being here. Thank you so much for having me.
And best of luck with the future of imaging, whatever it might look like.
Thanks a lot. We'll talk again soon, I hope.
Sounds good.